This chapter will introduce overview of machine learning. You will learn machine learning and artificial intelligence, the basic concepts and process of machine learning, the types of machine learning, and the development history of machine learning in this chapter. In this lesson, we will introduce artificial intelligence and machine learning. The first section introduces the knowledge of artificial intelligence and machine learning. In the past 2 decades, the ability of human beings to collect, store, transmit, and process data has been rapidly improved. A large amount of data has been accumulated in every corner of human society, and computer algorithms that can effectively analyze and utilize data are urgently needed. Artificial intelligence has just met urgent needs of the era and has made great development and received extensive attention. Today, artificial intelligence has also been closely related to ordinary people's lives and has many applications in face recognition, voice recognition, machine translation, intelligent security, and smart home. Face recognition is mainly used for identity recognition. By using fast face detection technology, the face can be found in real time from the monitoring video image and compared with the face database in real time so as to achieve fast identification. Voice recognition is a biometric method to automatically identify the speaker according to the speaker's physiological and behavioral characteristics, which can be used in non-contact biometric recognition. Machine translation is used the power of the machine to automatically translate the text of one natural language into another language. Intelligent security can implement automatic monitoring and management of security system. Smart home is a kind of living environment which takes residents as the platform, integrates the facilities related to home life by various scientific and technological means, constructs an efficient management system of residential facilities and family schedule affairs, improves the safety, convenience, comfort, and artistry of home, and realizes the living environment of environmental protection and energy saving. Human intelligence can be divided into 7 categories: verbal linguistic, logical mathematical, visual spatial, bodily kinesthetic, musical rhythmic, interpersonal social, and intrapersonal introspective. We call ourselves Homo sapiens, man wise, because our intelligence is so important to us. For thousands of years, we have tried to understand how we think, that is, how a mere handful of matter can perceive, understand, predict, and manipulate a world far larger and more complicated than itself. The field of artificial intelligence, or AI, goes further still. It attempts not just to understand, but also to build intelligent entities. And what is artificial intelligence? Artificial intelligence consists of 2 parts. One is artificial and the other is intelligence. Through research, simulation, extension, and expansion of natural intelligent entity represented by human, and then build artificial intelligent entity. In this process, many theories, methods, technologies, and application systems in the field of artificial intelligence were born. The concept of artificial intelligence was born in 1956 by John McKenzie and several other researchers at Dartmouth Conference. The proposal of the meeting stated that we propose that a 2-month, 10-month study of artificial intelligence be carried out during the summer of 1956 at Dartmouth College in Hanover, New Hampshire. The study is to proceed on the basis of the conjecture that every aspect of learning or any other feature of intelligence can in principle be so precisely described that a machine can be made to simulate it. And the time will be made to find how to make machines use language, form abstractions and concepts, solve kinds of problems now reserved for humans, and improve themselves. We're seeing that a significant advance can be made in one or more of these problems if a carefully selected group of scientists work on it together for a summer. The concept of artificial intelligence is that AI is a computer program that makes reasonable actions and obtains the maximum benefits according to the perception of the environment. In the figure, you see the definitions of AI laid out along 2 dimensions. The dimensions on top are concerned with thought processes and reasoning, whereas the ones on the bottom address behavior. The definitions on the left measure success in terms of fidelity to human performance, whereas the ones on the right measure against an ideal performance measure called rationality. A system is rational if it does the right thing, given what it knows. The research and development of artificial intelligence has a history of many years. During this period, scholars from different disciplines or academic backgrounds have made their own understanding of artificial intelligence and put forward different views, resulting in different academic schools. During this period, symbolicism, connectionism, and actionism had a great influence on the research of AI. The school of symbolicism holds that the basic unit of human cognition and thinking is symbol, and the cognitive process is an operation on the representation of symbols. Connectionism is an intelligent simulation method based on neural network, connection mechanism, and learning algorithm between networks. Its principle is mainly the connection mechanism and learning algorithm between neural network and neural network. This school believes that artificial intelligence originates from bionics, especially the study of human brain model. Actionism is a behavioral intelligence simulation method based on perception action. It originated from a school of psychology at the beginning of the 20th century. It believed that behavior is the combination of various body reactions used by organisms to adapt to environmental changes. Its theoretical goal is to foresee and control behavior. A popular definition of artificial intelligence, also an earlier definition in this field, was proposed by McKenzie at Dartmouth Conference in 1956. But this definition seems to ignore the possibility of strong artificial intelligence. The view of strong artificial intelligence holds that it is possible to create intelligent machines that can really reason and solve problems, and such machines can be considered as perceptive and self-conscious. The weak artificial intelligence, which is opposite to the strong artificial intelligence, thinks that it is impossible to make intelligent machines that can really reason and solve problems. These machines just look like intelligent ones, but they don't really have intelligence, and they don't have autonomous consciousness. The development of artificial intelligence has experienced 3 ups and downs, which can be divided into 7 stages, namely the gestation, the first boost, the first trouble, the second boom, the second trouble, the recovery period, and the growth boom. 1943 to 1950 is the gestation of artificial intelligence. 2 undergraduate students at Harvard, Marvin Minsky and Dean Edmonds, built the first neural network computer in 1950. The SNARC, as it was called, used 3,000 vacuum tubes and a surplus automatic pilot mechanism from a B-24 bomber to simulate a network of 14 neurons. Later at Princeton, Minsky studied universal computation in neural networks. His PhD committee was skeptical about whether this kind of work should be considered mathematics, but Von Neumann reportedly said, "If it isn't now, it will be someday." Minsky was later to prove influential theorems showing the limitations of neural network research. There were a number of early examples of work that can be characterized as AI, but Alan Turing's vision was perhaps the most influential. He gave lectures on the topic as early as 1947 at the London Mathematical Society and articulated a persuasive agenda in his 1950 article, Computing Machinery and Intelligence. Therein, he introduced the Turing test, machine teaming, genetic algorithms, and reinforcement learning. He proposed the child program idea, explaining, instead of trying to produce a program to simulate the adult mind, why not rather try to produce one which simulated the child? The concept of artificial intelligence was born at Dartmouth Conference in 1956. It proposed that an attempt will be made to find how to make machines use language, form abstractions and concepts, solve kinds of problems now reserved for humans, and improve themselves. 1956 to 1974 was the first substage of artificial intelligence. Neil and Simon already had a reasoning program, the logic theorist, about which Simon claimed, "We have invented a computer program capable of thinking non-numerically and thereby solve the venerable mind-body problem." Soon after the workshop, the program was able to prove most of the theorems in Chapter 2 of Russell and Whitehead's Principia Mathematica. Russell was reportedly delighted when Simon showed him that the program had come up with a proof for one theorem that was shorter than the one in Principia. In 1958, McKinsey defined the high-level language Lisp, which was to become the dominant AI programming language for the next 30 years. 1974 to 1982 was the first low point of artificial intelligence. Because the theory and method of artificial intelligence are not complete and the computing ability restricts the application research, the goal of artificial intelligence is difficult to achieve. In addition, in 1973, Lahil report mentioned that the disappointment felt may be analyzed into 2 kinds: work in the advanced automation and computer-based CNS. Research of Section 2 has some respectable achievements to its credit, and achievement in such categories of work with rather clear aims is clearly discernible, but to a disappointingly smaller extent than had been hoped and expected, while progress in building robots has been even slower and more discouraging, tending, as explained in Section 2, to self-confidence in whether the field of research called AI has any true coherence. In the meantime, claims and predictions regarding to the potential results of AI research had been published, which went even further than the expectations of a majority of workers in the field, whose embarrassment had been added to by the lamentable failure of such inflated predictions. Lighthill report formed the basis of the decision by the British government to end support of AI research in all but 2 universities. 1982 to 1987 was the second upsurge of artificial intelligence. In 1981, the Japanese announced the 5th Generation Project, a 10-year plan to build intelligent computers running Prolog. Taking Stanford University as a representative, the large-scale construction of knowledge base has been carried out. In the mid-1980s, at least 4 different groups reinvented the backpropagation learning algorithm. The algorithm was applied to many learning problems in computer science and psychology, and the widespread dissemination of the results in the collection parallel distributed processing caused great excitement. In 1982, the physicist John Hopfield proved that a new type of neural network, now called Hopfield network, can learn and process information in a new way. In 1983, Lise Valiant published a series of Learnable. The second cold winter of artificial intelligence was 1987 to 1993. Expert system was declining because knowledge cannot be expressed by experts by hand but by automatic learning. Japan's 5th generation failed to meet the target. Personal computers made by Apple and IBM are improving. These computers do not use AI technology, but the performance is better than the expensive LISP machine. As the market of AI hardware shrinks sharply, the research funds are cut back. AI has experienced the second cold winter. Since 1993, it is the third wave of artificial intelligence. The period of stable development from 1993 to 2006, statistical learning theory becomes the main means. In 1997, it took IBM's Deep Blue just 90 moves to defeat world chess champion Garry Kasparov, a stunning finale to an epic week-long battle of man versus machine. In 2005, DARPA's winning vehicle was Stanford University's study, the stock diesel-powered Volkswagen Touareg R5 that managed to complete the entire course in 6 hours, 53 minutes and 58 seconds. In 2011, IBM's Watson robot won the $1 million prize of the intelligence contest Jeopardy! Since 2006, artificial intelligence has been developing rapidly, which is based on algorithms, data, and computing. In 2006, Jeff Hinton published a science paper which opened the prelude to deep learning. The paper shows how to use complementary prior to eliminate the explaining away effects that make inference difficult in densely connected belief nets that have many hidden layers, and introduces the whole system of machine learning, especially the method of restricted Boltzmann machine and contrastive avoidance learning. It brings the neural network back to the people's attention and makes it possible to use the single-layer RBM self-coding pre-training to make the deep neural network training possible. In 2011, Google launched the deep learning project Google Brain to recognize human and cat faces. When computer scientists at Google's Mysterious X Lab built a neural network of 16,000 computer processors with 1 billion connections and let it browse YouTube, it did what many web users might do. It began to look for cats. The brain simulation was exposed to 10 million randomly selected YouTube video thumbnails over the course of 3 days, and after being presented with a list of 20,000 different items, it began to recognize pictures of cats using a deep learning algorithm, despite being fed no information on distinguished features that might help identify one. Picking up on the most commonly occurring images featured on YouTube, the system achieved 81.7% accuracy in detecting human faces, 76.7% accuracy when identifying human body parts, and 74.8% accuracy when identifying cats. In 2015, AlphaGo defeated the Go World Champion. AlphaGo is the first computer program to defeat a professional human Go player, and is arguably the strongest Go player in history. DeepMind created AlphaGo, a computer program that combines advanced search tree with deep neural networks. These neural networks take a description of the Go board as an input and process it through a number of different network layers containing millions of neuron-like connections. One neural network, the policy network, selects the next move to play. The other neural network, the value network, predicts the winner of the game. DeepMind introduced AlphaGo to numerous amateur games to help it develop an understanding of reasonable human play. Then we had it play against different versions of itself thousands of times, each time learning our mistakes. Overall, AlphaGo improved and became increasingly stronger and better at learning and decision-making. This process is known as reinforcement learning. AlphaGo went on to defeat Go World Champions in different global arenas and arguably became the greatest Go player of all time. The AlphaGo mentioned above uses reinforcement learning in machine learning of artificial intelligence. And machine learning is a way to achieve artificial intelligence. The most basic method of machine learning is to use algorithms to analyze data, learn from them, and then make decisions and predictions on the events in the real world. Different from the traditional hard-coded software programs to solve specific tasks, machine learning uses a lot of data to train and learn how to complete tasks from the data through various algorithms. Thanks for your watching.